All right, so one of the things you have to be able to do is solve an absolute value inequality. And notice that this is a less than absolute value inequality. And when you're solving an absolute value inequality, this one in particular, let's think about what the solutions are, because you could easily look at this since it's just the absolute value of x and determine the solutions on a number line. So if I look at this on the number line, what's one of the solutions to that inequality, to the absolute value inequality? The absolute value of what number is less than 7 will be a solution. Anyone? 5. Sure, 5 is a solution, so I'm going to put 5 right here. I'm going to put a closed circle because remember closed circles means that's a solution. 5 is a solution because what's the absolute value of 5? Absolute value of 5 is 5, and 5 is less than 7. Is that the only solution? No. How many are there, do you think?
Infinite.
An infinite number. What's another solution?
3.
3. All right. The absolute value of 3 is 3, and 3 is less than 7. What about someone this? So what? Let's say 0. 0 is a solution, right? Because the absolute value is 0, 0, and 0 is less than 7. What about someone this side? Give me a number on this side.
-14.
Okay, so here's -14. Is -14 a solution? No, because absolute value -14 is a positive 14, and 14 is not less than 7. So what would be the lowest bound in terms of your solutions? -7. So here's -7. Now, the absolute value of -7 is what is it? 7. Is 7 less than 7?
No.
No, 7 is equal to 7, right? So when I put the little closed circles over here, I'm going to put a open circle in this one. So remember, the open circle from what we talked about last time when we did linear inequalities means that that's not a solution. But all these numbers here, all these real numbers are solutions, all of these. Now notice that when y'all gave me solutions, you gave me integers, but there are decimals in here, right? -1.2 is a solution. So it doesn't have to be just integers. So any real number, rational or irrational. And the solutions are from -7 all the way to what? +7 with an open circle, because 7, the absolute value of 7 is 7, and 7 is not less than 7. 7 equals 7. So when you look at this, in terms of an inequality, I can indicate that all of my solutions are between what two numbers? -7 and a +7. So that is your solution set in terms of an inequality. So what I found was that my solutions are any real number that is between -7 and 7. So what this means, if you hear the words right here, this says that x is less than 7, and at the same time, x has to be greater than a -7. So notice when I read that, I read it as I said and. So some of you, when you turned in that I forgot which worksheet was the absolute value equations? No. Yes. So one of the equations, and when you broke it apart, you forgot the word and. So the word and's necessary because the absolute value less than involves the word and, intersection. And means intersection. And the greater than is the word or, which means union. So that worksheet, if you left the word and off that was due yesterday, you lost 0.2 points. I just took off 0.2. So if that was the only thing you missed, then you got a 9.8 out of 10 instead of a 10. All right, now,
Do you mind repeating what you said the and term is for? Or means.
so there was a worksheet you turned in that looked something like this. You had -2 is less than x plus 4 is less than 6. Okay? The way that we did it in class was very simple. We just subtracted 4 from all parts, right? That's what we did in class last week. Now, in the videos, I did it two ways. I did it that way, and then I split it apart. And in the video, I said splitting it apart is a little bit more work. This is quicker. -2 and a -4 is a -6. Is less than x is less than 6 minus 4 is 2. There are your solutions. Your solutions are from, in interval notation, from -6 to 2. What some of you did was you didn't do it that way. You said, well, x plus 4 is less than 6, and then you wrote also x -2, well, or you said x plus 4 is greater than -2, which is true, but when you did that, you left the word and off. Because when you break it apart, like we're going to do with the absolute value greater than, you're going to need the word or. So in the video, when you saw the video, I did not write it like this. I wrote it like this with the word and. And I said that and here means intersection. So some of you, when you turned in your worksheets, you forgot the word and if you split it apart. What was your question?
Yeah, but I mean, I was considering that as part of my scratch work. It wasn't part of the answer.
When you look, when you look at the examples I gave you, I always put the word and in there. The word and is necessary. Because I don't know if you think this is an intersection, or I don't know if you think this is a union. Those are two different things. So if you put the word and, I kind of think that, hey, this person knows that we're dealing with an intersection of two graphs, or two solution sets. Okay? All right. So then from all of this, then the way you're going to do these problems, if you have an absolute value less than, is if you look at this with what we ended up with here, what was inside the absolute value bars is what's in the middle. So we have x, and then you're going to say x is less than 7, just like this right here. And at the same time, x has to be greater than a -7. So all you do when you rewrite this without the absolute value bars is you just write it as a compact statement, like this, as a compound inequality. So you have x is less than 7, and at the same time, x is greater than -7. Notice the numbers on the outsides are opposites. They're opposites. So if you have something like number 2, and let's say number 2 is I always lose those problems. All right, so here's number 2. Let's say number 2, I had the absolute value of x plus 6 is less than or equal to 3 this time. All right, so how are you going to set this up? It's an absolute value less than, so since it's less than, think and. Less than, and. So that's going to be intersection. But don't split it apart into two separate inequalities. Leave it in this compact form. It makes things a lot easier. So this is a less than. In a little while, you can look at greater than. Those are written two different ways. So based on what we talked about with absolute value of 7, absolute value of x is less than 7, how are you going to rewrite this without the absolute value bars? No, the x plus 6 less than or equal to 3. And at the same time, x plus 6 has to be what? greater than or equal to a what? Nope, nope, nope. Okay, let's do this again. This solution set says x is less than 7, and at the same time, x has to be what? Greater than a negative 7. Opposites on the outsides. Okay, we're going to do this again. X plus 6 is less than or equal to 3, and at the same time, x plus 6 has to be greater than or equal to a what?
-3.
Negative 3. And then all you do, just like you did on the last worksheet, is just get x by itself. One more step and you're done. What are you going to do to all three parts?
Divided by 6.
Not divide by 6. You're adding 6.
Subtract 6.
Subtract 6. And so I get negative 9 is less than or equal to x is less than or equal to a negative 3. So all of my solutions are any real number that's between negative 9 and negative 3. So if you were to graph this, it would look like this. So here's negative 9, here's negative 3. I'm going to go ahead and use brackets. So we're using brackets because of the equal sign. So bracket going to the right, bracket going to the left, and you're shading in everything. Now, what is the interval notation? Interval notation. What's the interval notation?
Close bracket, -3.
Okay, bracket, negative 9, go from left to right.
Oh.
Why'd you say negative 3?
Because that's up to where it goes. It's more
I didn't hear, I'm sorry, I must have not heard you say negative 9 first.
-9, comma, -3,
Yeah.
close bracket.
Yeah, okay. All right, so there's your interval notation. So notice all of the absolute value less thans are set up this way. As that compound inequality, the same compound inequality you had in that last worksheet you turned in. So we're going to do one more with a less than. So let's say we had absolute value of 3x minus 1 divided by, I'm sorry?
You can't see it at the
Oh,
bottom.
I'm sorry. All right. So the absolute value of 3x minus 1 divided by 2 is less than 6. All right, so we have an absolute value less than. So with the less than, think and, that compound inequality. So you can write it as one compound inequality. So rewrite this without the absolute value bars. That's your first setup. So what are you going to write?
X minus 1 over 2.
No. So look at the right hand side. So the right hand side, see this right here? The right hand side is this without the absolute value bars, right? The right hand side right here is this without the absolute value bars. So the right hand side is going to be what? This without the absolute value bars.
Didn't I just say it? I thought I said it.
You said greater than. It's not greater than, it's what? Less than. Less than what? 6. All right. And at the same time, 3x minus 1 divided by 2 has to be what? Greater than negative 6. So there's your setup. All right, so what's the next step?
Multiply by 2.
Multiply all parts by 2. So times 2, times 2, times 2. All right, what's 2 times negative 6? Negative 12. It's less than. Now what's the left, or what's in the middle? What's in the middle?
3x minus 1.
Yep, the 2's divide out, right? So look at 3x minus 1 is less than 12. Okay, a couple more steps and you're done. What's the next step? Add 1 to all parts. All parts. So what's the left-hand side?
So it's negative 12. No, it's negative 11.
It's less than
3x
is less than?
11.
Nope.
13. I'm sorry.
All right, what's the next step?
Um,
No, you're multiplying by, your 3 is a coefficient. You're not saying x plus 3, then you would subtract. This is 3 times x. Divide all parts by 3. And so you get negative 11 thirds is less than x is less than 13 thirds. So all of your solutions will be any real number between negative 11 thirds and 13 thirds. So notice how absolute value less than looks, how you set it up. Now the interval notation will be parentheses, negative 11 thirds, comma, 13 thirds, parentheses, right? That's interval notation. All right, so that's how you set up the absolute value less than. Now we're about to do absolute value greater than. That setup is different.
So I have a question. What do you feel like is the difference between it that would make it more confusing?
Say it again.
What do you feel like is the difference between the less than and the greater than that would make it more confusing, or is it kind of the same? How can I explain? The same, I guess, work to get the solution to the problem.
They're written differently.
They're just written different.
The setup is different. Yep. All right. So in number 4, all right, so here's number 4. So a while ago we did absolute value of x is less than 7, right? Now we're going to do absolute value of x is greater than 7. Two different problems. They're both inequalities. They're both absolute value inequalities, but one was less than, the other was greater than. And when we started absolute value less than, we looked at a very simple example. Absolute value of x is less than 7, and we looked at the graph and we saw what the solutions looked like. So everything was between a lower number and a upper number. And so that's how it looks. So all of these look the same way as these compound inequalities. So we're going to do greater than the same way. We're going to ask ourselves, what are some solutions? And then we'll see how to go from there. Give me a number whose absolute value is greater than 7. 8. So here is 8. The absolute value of 8 is 8. 8 is greater than 7. So 8 is a solution. What else? Negative 10. I'll put negative 10 right here. Negative 10, the absolute value of negative 10 is a positive 10, and 10 is greater than 7. So negative 10 is a solution. What else? 0. Okay, let's think about 0. The absolute value of 0 is 0. 0 is not greater than 7. So 0 is not a solution. What about 9? Yes. What about 9.8? Yes. What about 20? Yes or no? Yes. So in fact, I can say it looks like anything bigger than 8 is a solution in it.
I'm confused with the negative 10.
What's the absolute value of negative 10?
10.
Is 10 greater than 7? So the 10 is a solution. Negative 10 is a solution. All right, now, here's negative 7. right here. What about negative 7.5? I'm sorry, positive 7, excuse me. Here's positive 7. What about 7.5? Is 7.5 a solution?
Yes.
Yes. So I put a dot on here. What about 7.1? Is
Yes.
7? Yes. In fact, anything
Above 7.0 is
it's actually okay. So yes, but anything above you said 7.0, so you mean 7, right? Like
yeah.
so 7.01 is a solution. 7.00008 is a solution. Okay. So basically I'm going to put parentheses all the way to the right.
So on the opposite side,
On the other side,
with negative 7.
negative 7, good.
Same.
Okay, so be
So you would put it all the way
to the left. Yep.
Well, would you have to write it in the initial location?
Write in what now? Say it again.
She wanted to know, would you have to write it in interval
Yes.
notation?
Yep. You sure would. Okay. Now before we do that though, notice that when we did less than, there was a lower bound and an upper bound, and everything, all the solutions were between them, right? You saw, when you looked at this, you saw one interval, correct? One set. Over here, when you go from left to right, you see an interval here, and you see an interval here, don't you? So it's kind of like you have two distinct graphs of your solution set. So that's one of the differences between how a less than looks and a greater than. So in terms of let me do the inequality first, and then we'll do the interval. So when we did this, we said all of the x's, which means my solutions, would be any real number between negative 7 and 7. That's what this is. This means this now. This part right here, because I have two things, this part here says that x has to be less than what?
Negative 7.
Negative 7. This says x has to be what?
Greater than 7.
Greater than 7. All right, now, to make it better, you have to say this. My solutions would be any number less than 7, negative 7, excuse me, or is needed, or any number greater than 7. So the or is the idea that union. So your solution set would be the union of those two sets. So the solution of this absolute value inequality would be the union of those two sets. So the or is needed here. Now, how do you write this in interval notation? And on MyLab, you're going to need to write it like this. You're going to need this symbol in MyLab. All right. So from left to right, remember the arrow's pointing towards what numerical or what number idea? Negative infinity. So you're going to go from negative infinity, comma, all the way to what number? Negative 7 with a parentheses. R, remember we said R is union, right? So you're going to say U for union. And then what's this as an interval notation? Parentheses 7 all the way to what? Infinity. Okay.
Do you mind telling us how we're going to put the infinite in MyLab? Is there a symbol
Yeah, so when you go to MyLab, at the bottom, there's the infinity symbol.
in the keyboard? Okay.
Yep.
Good.
Mm-hmm. Not your keyboard, but when you MyLab.
Yeah, the
Yeah.
option in MyLab.
Yeah. Yeah, I think last time we saw that when we went in, the infinity symbol.
I probably didn't pay attention to it.
That's okay. But yeah, it's there.
Okay.
All right. Now, so when we did the absolute value less than from number 1, we saw how to set it up. So when setting up an absolute value less than, you're going to write it as a compound inequality statement like this. So you're going to say this without the absolute value bars. X plus 6 is less than or equal to 3, and at the same time is greater than or equal to the opposite, negative 3. Same idea here. Notice opposites. This is 7, right? Yes. Yep.
Does the formula change for equal to when it's equal to besides us like shading in a line? When we put it on the graph?
You're talking about absolute value equation or absolute value inequality?
Whatever this is.
These are inequalities. So if you put, you're talking about this being an equal sign?
Yeah, that
We're gonna
would
do
make
one
it
in a little while.
equation, right? That'll make it the absolute value equation?
No, no. Absolute value equation doesn't have an inequality symbol in it.
Okay. All right, let me look.
Yeah. So I'm not sure if you're saying if there was an equal sign
Yeah,
in
that's
here.
what I'm implying.
The only thing that would change with that instead of parentheses, it would be
A bracket.
brackets.
Okay,
Yeah.
thank you.
Yeah. All right. So when rewriting this, you're going to rewrite this without the absolute value bars. That's your first step. And notice you want to go from here to here. You want to go from here to here. So just like before, first thing you're going to write is this without the absolute value bars. So what is this without the absolute value bar?
X is greater than 7.
That's this right here. Okay? Remember though, that's greater, so think greater, greater, or. Okay, greater, or. So you need the or. So you're going to say x is greater than 7. You're going to say x is greater than 7, or x is, and then you just change everything around. So greater than becomes less than, and then its opposite, which is a negative 7. So that's how you do it. All right? Oops. Yes?
Question, is there a way to write it all together?
Nope.
without the
You
or?
cannot
Okay.
do, you'd be surprised how many students want to write this like we did the previous one. No, the absolute value, the inequality symbols must be pointing in the same direction. So when you rewrite it, and students still do this, so when you rewrite this, I guess what you're saying is you want to say x is greater than 7 and then less than negative 7. I'm assuming that's what you mean.
Yes.
Okay. Well, first of all, notice that the inequality symbols are not in the same order. Okay. So you're saying this right here. Saying x is greater than 7. Now remember, when you write it like this, that becomes an and statement. So x is greater than 7, and at the same time, x is or negative 7 is greater. So look, negative 7. You're saying negative 7 is greater than 7. Is that true? No. So right away, you know that there's some confusion here, because you're saying negative 7 is greater than 7. You're also saying negative 7 is less than 7. So these things are not being in the same direction.
So you can't write it like that if they're not going in the same direction.
You're right. But also keep in mind that in our statement, you can't write it like that anyway, even if you wrote it like this. You can't, because that's an or statement. Because when you write it like this, when you write it like this, you're saying your solutions are from negative 7 to 7. Is that true? Is this the same as that? No. All right, so be careful when you're dealing with these two different kinds of inequalities. Students want to always do both of those the same way, and they're not done the same way. This is strictly an or statement. This is an and statement. Greater than, greater, is an or statement. Less than is an and statement. An and statement, you can write it as a compound like this. So you're just going to have to practice with this and always think of a simpler example like we just did.
Are we about to do one more?
Yes.
Okay.
So So let's say we had the absolute value of x minus 6 is greater than or equal to 3.
Professor,
Uh-huh.
sorry, real quick, do you want us to rewrite it, like how it says, where it says underneath the little line, it says x is less than -7 or x is greater than 7? Do you want us to write it as, like, the x is greater than 7 first every time, or does it really matter?
It doesn't matter.
Okay.
No. The way I'm going to do it though will be so I'm going to rewrite this without the absolute value bars. So I'm going to say x minus 6 is greater or equal to 3. Then we know that this is an or statement. So we're going to say or, and then you're going to say x minus 6 is then what? Everything changes now. Less than or equal to a -3. And so once you get to that point, the rest is easy. So how do you solve this linear inequality? Add 6 to both sides, so you get x is greater or equal to 9 over here. Add 6 to both sides, you get x is less than or equal to 3, right? Okay, now you D2, so the directions on my lab and on your worksheet is going to say write your solution in interval notation. But let's look at what this looks like in terms of a graph. So in terms of a graph, here's 0. In terms of a graph, I guess I should have put 0 closer on this side. So here's 0. So in terms of a graph, this part says my solutions will be any number greater than or equal to 9, right? So let's say this is 9 here. Bracket or parentheses? Bracket going to the right, and make sure you draw an arrow. Right here. Okay. And then over here, x is less than 3, so here's 3. Bracket or parentheses?
Bracket.
Going which way?
To the left.
To the left.
With the arrow.
With the arrow, just like that. And then sometimes when students graph it, it's easier for them to do the interval notation. You just go from left to right. So what is this in terms of interval notation?
Open bracket.
Say parentheses.
Okay, parentheses. I'm lost.
This arrow is pointing towards negative infinity, isn't it?
Okay, parentheses, infinity.
Negative infinity.
Negative infinity.
3.
3.
With a? Okay, there's no such thing as closed parentheses. It's bracket. Okay?
I thought I just said bracket.
I thought someone said closed parentheses.
I did say close parentheses, but when I started, oh, I see. I'm picking up what you put down.
Okay.
It's cool.
Union?
And then,
Close bracket?
no,
Open
open bracket,
Open bracket.
9,
9.
comma, infinity.
Okay.
Close parentheses. I can say close parentheses.
Yeah, so I guess what you mean by closed parentheses, the parentheses pointing.
Inward.
Yeah, okay. All right, I see what you're saying. Okay. Yeah. But you.
But I see now is basically showing the arrow will be the parentheses, and where it starts would be the brackets because it's equal to.
Yeah. So we talked about the fact that whenever you're dealing with infinity, negative infinity, you're always going to use parentheses.
Okay, let me note that.
So when you're dealing with my lab, let's see. So look something. So when you do my lab, you can't see this very well, but like the one we did earlier, where we had this. So it's going to say rewrite the inequality without absolute value bars. First thing you do. So is it A, B, or C, the one that you're going to use for absolute value less than? So when you look at my lab, you can't see this very well, but basically you have x plus 6 in the middle, and you have less than equal to, less than equal to, and then two things in the outside. Here, it just says x plus 6 is less than something. Here, it says x plus 6 is less than equal to something, or x plus 6 is greater than equal to something. Which of these would you set it up as?
C.
Okay, so remember, C has the R in it. R you use when you have absolute value greater than. This is an absolute value less than. So absolute value less than is where that thing that's inside the absolute value bars is in the middle.
So would it be A?
It would be A. So when you do, so you're gonna do this, and then in the boxes you would say, what's gonna go here? So you have x plus 6, what goes here, and what goes here? Negative 3. So negative 3 is less than equal to x plus 6, is less than equal to, and then what's over in that box?
Positive 3.
Positive 3. And then you solve it, and then you put your solution set in interval notation here. So that's how you're going to do the MyLab.
That's for the one coming up, correct?
Yeah, I hadn't signed it yet. Yeah. So I think this is 1.7. 1.7. Okay. Now,
And I think you said like over the time period, I think it's about like 6 of them. I think that's what you posted the other day.
yeah, there are two that expired.
Yeah, I did those two already.
Yeah. So there's one I think that's so the
I know there's one tomorrow.
yeah, the due dates are listed in the table. I put the due dates there. There's a just-in-time one due either tomorrow or the next day. So just look at the dates that's there and make sure you're keeping up with those.
They pop up on the calendar too on
Okay.
campus.
Okay, good, good.
I like
I
the
didn't know
to-do
that
list.
because I always logged into the Pearson to actually see them. I'd never
Yeah,
seen
you
the
go to
calendar.
your calendar or your to-do list, they'll pop up.
Yeah, just try and keep up with those because it's a lot of work you have to do.
Redoing it until you get it right.
Yeah, because
Yeah, so it syncs to your grades nightly, but until the due date, you can always improve your score.
And then when I saw you say you could keep redoing them and like similar question or something, I just kept on the time.
Yeah, it's helpful to look at like an example question.
Yeah, that's what I do.
Or like I really like because I've used Pearson in a previous class. So I basically would take the example problem, like plug in the numbers and do that until I like really get the hang of it.
I do that too.
Like I'll try to solve.
And if you get it wrong, you can ask for a similar question and redo it, and then it gives you the answer.
Okay, because I've been doing them and trying to keep up with them, but the only way that I'm actually able to see them, I don't know if I don't have my calendar set up right, but it's like I have to actually go into Pearson, but I do it on like
So there are some special cases. You'll notice that when you looked at the MyLab example, you'll see one of the choices down here is the solution set is the empty set. See that? Solution set is the empty set. That was one of your choices. But all the problems we've done so far, you've had solutions, right?
Can we do one without a solution? So we
We're about to do number 6.
great.
So you need to be careful when you're looking at these absolute value inequalities. First of all, you want to make sure it makes sense. And if it doesn't make sense, then there's probably no solution. So when we looked at this example here, the first, whoops, let me do a less than. When we looked at this right here, you ask yourself, no matter what x is there an x, is there a number for x such that this side, when I take the absolute value of it, is going to be less than or equal to 3? Are there numbers whose absolute value is less than or equal to 3? Yes or no? Yes. So I'm going to have solutions, right? Okay. Over here. Are there numbers whose absolute value is less than 6? Yes. So we're going to have solutions. So when I look at number 6, and I ask myself, are there numbers whose absolute value is less than -3? Yes or no?
No.
No, because the absolute value of a number is always positive or 0. The absolute value of a number is never negative. So when you get the absolute value by itself, when the absolute value is by itself, and you see something like this, ask yourself, am I going to get solutions? And if you say yes, then you go ahead and you work it out. But when I look at this, there is no number whose absolute value is less than a -3. Because less than -3 means what kind of numbers? No. Be careful. Look, here's -3, and then here's less than. All these numbers I'm shading are what kind of numbers? Negative. Absolute value of a number is always positive or 0. So right away you can say no solution. No solution.
So we automatically assume that it's.
Wait, can you repeat the last thing you said? You said, before you said no solution, you said negative.
Or
you said
0.
The absolute value of a number is always positive or 0.
Okay.
It is never negative.
So we see a negative number, no solution.
Well, if you see the absolute value,
In the absolute value.
if you see the absolute value on the left side and you see less than a negative number, then you're going to say no
have a
solution.
question.
But don't memorize that, understand that.
Can you give us like a series of these? Like, can you list about 3 of them right now that I could see visualization and say for sure that it's like no solution?
Is that no solution?
No, that is a solution. It's a positive number.
Positive number or 0, is that less than or equal to -8?
So that would.
X plus 3 is greater than -8.
No. Ask yourself, are you going to get solutions? Is there a way in which the absolute value of x plus 3 is ever going to be negative? No. The absolute value of x plus 3 is going to be positive or 0. So that has no solution. Are you good with that?
Yeah.
Okay, now what about this? Are you going to get any solutions? You said yes, why?
Because no, wait, no. Yes, y'all say yes. Oh, I'm gonna hush because I don't know. I'm confused.
Huh?
Because it's 0, right? You said it has to be.
Positive or 0.
The absolute value number is always positive 0, that's true.
Be -3.
But then we gotta look at the sign.
What do you mean by sign? You mean the inequality symbol? Okay, what about it?
Solution.
Huh?
X plus 3 is greater than 0.
That's less than.
See, I gotta get that right. So
That's less than.
Say, in like in elementary school, when it's
the
Alligator
or
mouth.
the Pac-Man.
So if the mouth is open, that means it's
Less than.
It's less than. But if it's opposite of that, it's greater.
Because they want to eat the bigger number.
All right.
So yes, there's a solution, because -3
Wait, what's the
plus
Pac-Man
3
alligator thing?
would be 0.
If it.
Okay. So she's trying to think about this in terms of plugging in a number. All right. So listen, she's saying this. Well, if we let x be -3, now listen carefully. What's -3 plus 3? 0. What's the absolute value of 0? Is 0 less than 0? No. 0 equals 0. So do we have a solution? No.
That's what I'm saying. I was like,
Okay, now, what if I change it to this?
You know, I wish you could
Oh my gosh.
plug your brain in our head, but it's.
I wish you
yeah.
could. I could just borrow 25% of your brain.
Uh,
Cause I don't.
Okay, now look at this. Now, she says there's no solution for this one. And I'm assuming you're saying no solution because this, you said no solution. Is that why you're saying that?
But you have, it can't equal zero.
Okay, you do have a solution this time. In fact, what is it?
It's equal to zero, it's zero.
But what is a solution?
Oh.
What is x? What must x be?
-3.
-3. Solution is -3
Because of the sign, is it because it's?
because the equal sign's there.
You know,
Yeah.
So wait,
Yeah.
and this is like, what's the wait? So what's the like? I'm not trying to be funny or anything. So what's literally the difference between?
because it's
The-
equal to something.
So this is great, this sign right here is greater than or equal to? Is that what that means?
That's less than equal to.
Okay,
Less
see,
than
I need to
equal
write
to?
that back.
Oh.
I'm looking at
Okay, can you just write like
elementary
a note?
algebra.
Like I'm not trying to be funny or anything, but like just a notation of like the symbols real quick. So like,
Less than?
yes, okay, just so I can write this down.
Yeah,
Less than or equal to?
So sorry.
I'm so sorry, but I'm.
Also helps, like, whenever you're doing the number line, whatever, like, you're drawing arrows.
Greater than?
Right, and the way that the triangle points to, that's what the symbol is.
Greater than or equal to?
When I was doing my math, but it's like I confuse myself like that. Thank you for that. I
Mhm.
appreciate that. You're feeding my inner child.
So when you look at the videos, though, the videos you're going to see the same. You're going to see those things listed. Yeah, they're there as well. All right, we're going to do one more with absolute value inequality, and then we're going to leave at 7 because I got to make sure all those things are shut down.
Okay.
All right, 7. Let's say we had this. All right, now you are going to see something like this. 4 times the absolute value of 2x minus 3 minus 5 is greater than or equal to 11. All right, now it looks more complicated because you see more things there. But if you look at all the other problems we've done, the absolute value bars were by themselves. That absolute value expression was by itself. So what I need to do is I need to get this absolute value of 2x minus 3 by itself. Go ahead.
We're not going to distribute, we're just going to take the bars away.
Not yet.
Mm-mm.
I need to get the absolute value
gotta
of
get
bars
rid of
by
that.
itself.
4.
So I got to get rid of the 4. I have to also get rid of the
The 5.
negative 5.
So you're gonna add 5.
Add 5 to
each
both
side.
sides first. So we get 4 times the absolute value of 2x minus 3 is greater than 16.
Professor, why didn't we add the 5 to the 4 in the front?
Because it's I think it's an absolute.
So it's kind of like saying if I had 5x plus 6 is greater than 2.
Because they're
Would
on the
would
same
would you subtract 6 from this as well?
I see.
Yeah, they're not like terms.
terms. They're just in the same.
Yeah. So this is 4 times some expression with the
Okay, so
variable.
I do need to keep that, distribute property in my head.
Yeah. Now be careful because the absolute value bars are not parentheses. If that was parentheses, then you would distribute. But you got to be careful with the absolute value bars. That's not a parentheses. That's an operation. I'm taking the absolute value of some expression. Now, if you did distribute, it would still be fine. But if that was a -4, you need to be careful. So that's why when you're dealing with absolute value expressions and the 4's listed as a multiplication, the next thing I would do, so remember trying to get this by itself. So right now I'm multiplying by 4. What's the opposite of multiplying by 4?
Dividing by 4.
Yeah, so do that. if you distribute it, you would still get the same answer, but you gotta be careful, especially if that was a negative 4.
So 2x minus.
So you have the absolute value of 2x minus 3 is greater than 4. All right, once you get the absolute value expression by itself, you now know how to set it up.
Plus 3.
At 2x, be careful.
You have to take the absolute off.
Yeah, take the absolute value bar away, and then you're going to write an OR statement. So you're going to say what?
4.
2x minus 3 is greater than 4. Or 2x minus 3.
Is less than negative 4.
Yeah, and then you solve each one individually.
Okay, I'm getting this just a little bit, like,
I'm lost again. So
okay, so like, I get it, because, I don't know, it's kind of hard to explain now, but.
I guess, since now we have a solution, when it gets difficult, we just do the opposite.
Yeah, you just do the opposite. So like,
just like we did.
it was greater than, so now that it's less than, you're basically making it into a negative. If that makes sense.
Yeah.
Am I saying that correctly?
So you're in a way.
It's like, in a way, I don't want to confuse you. So I don't want to say it wrong.
The reason why I did a simple example was for you to see what the notation and the structure looks like. So when you have absolute value greater than, we did it this way, so you'll see how to rewrite it. So from here, you say, well, based on what I see, the absolute value of x greater than 7 means that I'm going to write it as two separate inequalities with the word or between them. So the absolute value of x greater than 7, first one I'm going to write is x is greater than 7 without the absolute value bar. Yes?
Okay, so the correct memory device, and correct me if I'm wrong, great or is or.
Yes.
Than and.
Yes.
So if it's less than, I'ma always do and if it's great or, I'ma always put or u.
Yeah, well, in your interval notations where you're going to put the u.
Okay, all right, I'm following.
Yeah, okay.
Now I get it, thank you.
All right. Okay. And then when we solve this at 3 to both sides, I get 2x is greater than 7. So what's x? Greater than what? 7 over 2. Or, and over here, at 3 to both sides, I get 2x is less than, what's that, negative 1? So what's x? Less than negative 1/2. All right? So your solutions would be any number greater than 7/2 or any number that's less than negative 1/2. But you want to put this in interval notation. Some students get confused how to write it when it looks like this. So it helps if you put this on the number line. So always put it in order. Negative 1/2 is going to go before 7/2. So if I look at x is less than negative 1/2, that means I'm going to put parentheses, because there's no equal sign, going to the left with an arrow. Over here, x is greater than 7/2 means parentheses going to the right. Okay, with don't forget your arrow. And now you know your interval notation, so you go from left to right.
Another question, and I know you probably said it, it's probably rhetorical, but the parentheses mean that it's an actual number or a real number?
No, the parentheses only implies that in this case, negative 1/2 is not a solution.
Okay.
If this was bracket, the negative 1/2 would be a solution.
Okay.
All right, going from left to right, what's the solution?
Open bracket, infinity, comma, negative 1/2, close
All right.
parentheses.
Negative infinity, comma, negative 1/2, parentheses, right? Union, parentheses, 7/2, comma,
infinity, infinity, close bracket. Oh, no brackets?
parentheses.
Parentheses.
Yeah, there's no equal signs. And whenever you use infinity, negative infinity, those have to be placed with parentheses.
Okay,
Mhm.
It's not been
All right, so that was section, 1.7, so that was 1.7. Okay?
Oh, yeah, 'cause it's easiest to use.
So we did one part, and that's as far as we'll be able to get to. Um, so just make sure you continue working on the rest of the agenda. The videos are there.
Sometimes
The
I
vid-
have to slow the videos down. I don't know if it's me
No,
or I feel like they move a bit fast. I don't know. It probably is just me.
Well, sometimes you do have to rewind and look at things
Yeah.
again. So,
utilize every resource.
Yeah, I try.
Mhm.